Welcome. In this video I'm going to show you how you can perform a paired samples t-test using Microsoft Excel. There are a few different methods of doing this. In this method I'll be using a way where you don't have to calculate the differences per pair. In another video I'll show you how you can actually do that with calculating each pair, and I'll also be going over a third method in another video where I'll be using the data analysis add-in. But this video is about not calculating differences per pair if for some reason you don't want to. Then the first thing to do is actually to remove any pairs with missing values. So for example, this one should be completely ignored. So we can simply do that by using equals is if or this one is empty, or if this one is empty, close the or, then don't do anything, otherwise return this value and close the parentheses. Now I'm going to be copy pasting this to the side, and I want actually the A not to change in that, so put a $sign in front of it, and also here in front of the B. You can press F4 on the keyboard to toggle between the options of $sign, so if you keep on pressing it will go over them. This is the way I want it. Press enter or control enter, and then simply copy it to the side, and then also copy this all the way down. So up till here in my example. Now you note that here this one is empty now, and this one as well. Then we need to determine the average and variance for each of these, which can simply be done by using the average function of the ones that are only useful. Note that if you have numbers up or below this column, then you should simply select the range, but I don't, so I can simply select the entire column C. And for the variance equals var, or if you like the newer ones, you can use var s or dot s. I'll use the old one, and again c double dot c. Now this was for the before, and copy paste for the after. Then determine the difference in the two averages, which simply will be this one minus this one. Then we need the number of pairs, which should be either count C or count D. Should produce the same result. Again, if you do have numbers above or below your table, then specify the exact range. Then the covariance between these two, so you can use the newer function covariance.s, that's the one you actually need, of C and semicolon or comma, depending on your system settings, versus D. That should give you 416. Now if you don't have a new version of Excel, or new, depending on when you're watching this video, you can actually convert the old one, which is a population one, to a sample one by simply multiplying by n and then dividing it over n minus 1. So if I use the old function covar and then use c double dot c semicolon d double dot d, it will get a different result, as you can see. But I can then simply multiply this by n, and then again divide by, and then n minus 1. And that should give me then the same result. Then the standard deviation of the differences, because we haven't calculated the individual differences because somehow you didn't want to, we can then use a complicated function or formula, which is the square root of the two variances. This formula should actually read variances. I'll change that later, but it's this one plus that one, and then minus 2 times that covariance. And then you can actually close the parentheses. So this formula should not be Sx, but it should actually be, let me change that, otherwise we get complaints, S and then x square. So indicating that these are the variances. Copy and up, paste, and this should be a y. Now the formula is actually correct. Then finally the standard error, and these are relatively straightforward calculation. So equals the standard deviation of the differences divided by the square root of the number of items, and then the statistic in itself is the d that we had up here divided over this standard error, which gives us minus 2.39. And to calculate the p-value, we need the degrees of freedom, which is the number of pairs minus 1, which is in this case 23. And then last but not least, we can calculate the p-value or the significance, which is then based on this t-value, but we should actually take the absolute value of it, otherwise we might get a small error. And then the degrees of freedom, that's this one, and we want actually two tails. You can also use the newer function called t.dist, and then let's go immediately for that. We want a two-tailed version, and then we only need to specify x and the degrees of freedom, and that should give us the same result. But of course also this one needs the absolute value, and now it all works. Okay, and that's how you can perform a paired samples t-test using Microsoft Excel. And in this case it's below 0.05, so most people would consider that significant. So there's a significant difference between these two averages.